So I can now finally start to crack on with the reassembly process of this rear suspension. I'm going to start by doing the universal joints into the upper suspension arms, and then I'll probably move on to the hubs. So I've just unbagged this universal joint here, so if I just pull it apart carefully, we can see that inside here we've got the needle roller bearings. You don't want them to be falling out, that's for sure. So each of those pops out, and then we've got, actually different to the original design of circlip, these clips hold them in once they're in place. I've been in with the Dremel on each of these to carefully clean out the retaining clip channel. These should all fit in really nice and easily. So with the assembly of the universal joint here, you can see that the grease nipple here is actually pointing to one side. Now, if I look at the assembly of this universal joint for the outboard one, the one that's going to be within the hub carrier, what I need it to do is actually be accessible by this access bung, this access hole that's in the universal joint shield. So that will actually sit on the shaft there, and I need it to be able to be accessed there. So this one needs to be pointing, in effect, inboard to be able to be accessed. So this first universal joint, you can see that I've already got both of these caps in. So what I'm going to do is show you how I go about doing this second one here. So I just use a small copper mallet so that I don't cause any damage on any of the caps. Circlip pliers. In this case, it's a 22mm socket, and I'll show you what I use that for in a moment. And then I've got the two circlets down here. So you need to carefully pop off each of the caps, put them to one side, and then with the joint itself, you basically just feed that in. Once you've got that in place, you can then pop one of the caps back in here. And of course, this is where having all of that, the inside of this area cleaned up properly really helps. So with that in place, you can then start to tap that into place. So now that that's got flush with the surface of the yoke, I'm using this 22mm socket, which is slightly smaller than the diameter there, to help knock it down the rest of the way so that I can get the circlip in. You don't need to hit it too hard. It does go down relatively easily. Actually feel it moving. So I can now start to see the place where the circlip's going to go. Okay, so the circlip, obviously it's just a question of squeezing that in, pushing it into place, and there we go, a nice satisfying click. Then flip it over, align the other cap, and tap it down in the same way. So I've now got two fully assembled rear half shafts. Circlips in place. I'm now going to tighten up the grease nipples and grease them ready to go. So I've done up the grease nipple with a 5/16 socket and injected grease with the grease gun here. You can see that there's grease coming out from the universal joint. Next, I'm going to load the inner and outer wheel bearings into the hub carrier. So before I start to drift the bearings in, it's just worth noting these are tapered roller bearings, so you can see the taper there, and obviously there's the rollers on it. The different sizes for the outer, so this is the outer here, and it sits on the, not the bottom shoulder, but the next shoulder up. Right, so that's really quite hot to the touch now. So two top tips I give when putting bearing races in. One is use an old one to help drift the new one in, and the second is to use one of these tools here. So I get the new mouse race the bearing. In fact, I can feel that's already pushing in due to the thermal expansion of the aluminium. So use the old one, which I've kept. Right, so that's now already pretty much flush, which is a really good sign. Now, you don't want to get this stuck, so I'm just going to use it a little bit more. Pop that out, and then use this tool to put it in the rest of the way. Okay, it can be misleading, this. You don't need to get it down to that bottom shoulder. It's already sitting on the one above. So what I'll do now is flip it over, do the inner bearing race as well. This one has a much more modern looking seal design. So rubber outer with a spring on the inside to keep that tight. Fair to say that took a little bit of persuasion to get in, but that oil seal is now in there. So what I need to do next is get the hub into place. So it would insert in there, but if you actually look at this old one, we've got the bearing and then we've got what they call the oil seal track that sits underneath this old bearing there. Now that doesn't come in with the bearings or anything like that. So I've gone to the old hubs and got one of them out. So as you can see, it fits in like that. In fact, sorry, it goes around that way. And then the hub will go in there. So that chamfer accounts for the radius of the machining on the hub here. I need to extract this one, get the bearing off there for the other side. This one shows the one that I've already cleaned up. So that bit will press down there. And then I need to get this bearing out and drift it down onto the hub there, turn it over, drop it in. So what I'm going to do is show you how to get this bearing off here so I can get access to that oil seal track. And it's actually taken me a while to get this bearing to start coming off. So I've got this bearing puller here, which obviously tightens in, gets underneath the bearing. And then it's got this mechanism to force that down and pull the whole lot up. It's finally starting to come off. And all of that to get at this part here. Just the water shedder in this case is just in the way. There it goes. Okay, give this a clean up and get ready to reuse it. So with the spacer in place here, I can now drift the bearing down on top. Okay, the change in noise tells me that that's now in place. Okay, so this should just drop in easily now. So if we now look from this side, what I need to do is drop the inner bearing in there and tap it down into place, not fully home because so now you can see there's plenty of movement or end float in the bearing. So when I tighten up the stub shaft into there, then I can use the hub nut to tighten it up to the right clearance. So my next step is to drop in the spline shaft. First of all, I need to put in this spacer and the oil seal track there. Then the oil seal goes around that before I then drop in the spline shaft. This is the replacement inner oil seal, and I'm not really impressed with the quality of it, to be honest. Firstly, it's gone rusty before I've even put it in. Secondly, the inner diameter of the seal here is too small. So if I get the spacer here, or the oil seal track as it's described in the handbook, it doesn't fit at all easily in there. And actually what's happening is because the outer diameter here is slightly too small as well, the whole lot is rotating within the hub when I turn the shaft. So what I've done is I've had a look at and cleaned up the old one. As you can see, that fits. I mean, obviously those were mating parts before, but that fits in nicely in there. There's a good seal around, and the outer diameter of this is slightly larger. So I'm not going to be struggling with any issues with that rotating. So that's what I'm going to be putting back in. But you really need to watch these parts because, you know, there has been some deterioration in quality, and maybe I can't remember whether I could have got a more expensive one than this, but really that's not good enough. I'm not happy with it. So it's much better to put the old part back in this case. So I just finished loading this bearing up with grease. so now I can get the hub nut on the end of the shaft in here, tighten that bearing up, measure the clearances. I've set up a steel plate on the hub here, and I've used the magnetic base here to hold the dial test indicator, which is set pretty much to 0. Now what I'm going to do is get some screwdrivers between the water shedder here and the hub to lever it up and see what I've got. So what this is showing is that I've got about 0.01 millimetre of end float. So if it's between 0.05 and 0.15, then I'm right in smack bang actually in the range of where I need to be, which is really good. So I've given the inside of the hub, and therefore the bearings, a good grease, and I'm now going to tap on the grease cap. What I'm going to do now is take the hub nut back out again, withdraw this so that I can then get on with the fulcrum shaft at the bottom here. First job is to put the bearing race in. So as before, I've just been heating the area up with the heat gun, and in fact, look at that, that's just going in nicely to start with, and then it's tightening a little bit up as it goes further down. In fact, I'm almost pushing that in as it is. Okay, so now for the other side. Right, so very carefully with this. To set up the fulcrum shaft, which is mounted in the vise here, so I've got a nut on it and just clamps it in the vise. You need to construct this 1, 2 or 3 times until you get it correct, and actually measure using our test indicator here to set the slack or play in the bearings. So the way to do that, this is use these spacers, and you just drop these onto the fulcrum shaft, drop a bearing in, and I'll now drop this in on top. And so that's now on the first bearing. Now I need to put the distance piece that goes in the middle, add really thin shims, add a stack of them, so that's probably going to be too much, and I put that on. In effect, that lengthens the tube before I then put the bearing for the other side into place. Now what I want to do is basically bolt this all up so that I can load those bearings and measure the amount of slack. Using more spacers in there, I can now tighten down, use this old nut here, tighten down this nut, and I should feel a load of slop in these bearings. Okay, so take that off. You can actually hear it and feel it. So the whole lot is sliding up and down because the bearings are not being allowed to sit properly in the race. So what I'm going to do now is take it apart again and take 1 or 2 of those shims out. You shouldn't really be able to feel any slop or hear anything at all. Right, so let's pop the bearing back out again. And then if I'm careful, I should be able to lift 1 or 2 of these shims back out again. If I just count them. Okay, so how many have I got there? I've got quite a few. I'll pop these 2 back on again. The shims tend to stick to the bearing as well. Right, so drop that back into place. Drop these spacers back on top. Torque the nut down again. You can actually hear it. There's still some sound there, but it's a lot less than last time. Really not very much at all. Okay, so at this stage, what I'm going to do is get the dial test indicator. Okay, so that's now in contact. Reset the dial to 0 where the needle's pointing. Now if I just get a screwdriver in at this point, there's actually still a little bit of air underneath it. Okay, after a little bit of setup, you can see that there's a very small amount of play, which indicates that there's 0.02 to 0.03 of a millimetre's worth of movement in that bearing, which is absolutely fine. So I'm now taking this apart again. I'm going to grease the bearings and reassemble. The final part of setting up these outer fulcrum shafts is getting the shimming right so that the distance between these two parts of the yoke means that you're not squeezing them in or there isn't a gap, basically. Get shims like this. So you can pop them in there, pop that back in, and the grease will probably just hold it. So if I now offer this up, what I'm looking to do is get this to be a really nice snug fit. As you can see here why the seals just get in the way at this stage. That's almost exactly right. Might need a shim taking out. It's worth noting actually that you can see where I've painted all of this. I've actually cleaned this face on both sides of this yoke down with carefully with a wire brush on the drill, just to get the contact face to be, because even the paint thickness makes a difference. What I'll do is I'll pop one out again here and have another go. So, okay, it just goes in now. So that means that, yeah, really don't want any play in there at all. So it only just goes in. So you can see here I've inserted the fulcrum shaft through. You can use a dummy shaft to make sure that the shims don't come out of position and get in the way and ruin everything. But as long as you're careful and check first, it's possible to get the fulcrum shaft through cleanly without. So I'm just going to start tightening up now and make sure I get the same amount of thread at each end of these nuts. Okay, with the threads evened up either side, I can now torque this down to 55 pounds-foot. One side. Okay, that's good. Right, so we'll see now. It's reasonably stiff, but that's okay. I mean, it feels to me like that's reasonably well set up. So you don't want it flopping around, but equally you don't want it completely solid either. So please join me next time when I'll be getting onto the inner fulcrum shafts and carrying on with the rest of the rebuild.